I welcome you all in this presentation related to the subject materials processing fundamentals and practical. In this particular presentation, initially we will be talking about the welding positions and the types of weld joints. Thereafter, we will try to see the welding procedure related aspects, what are the different things included in the welding procedure and what are the different aspects should be kept in mind while developing the welding procedure. And then we will be talking about the principle associated with the gas welding and arc welding like shielded metal arc welding. And in the shielded metal arc welding, we will try to see the role of the fluxes and the kind of the comparison of the arc welding processes. Okay, so let us go with the different types of the joints. So the classification of the weld joints is based on types of weld joint is based on the placement, how the components being joined are placed. If they are in the same level like this in flat position, then this is known as the flat welding. Okay, like this, and here the weld metal will be deposited in this manner. Okay, and if the plates are placed in overlapping position like this, okay, and then the weld is being made here using the fillet, then this is called lap joint, this is butt joint. Okay, so the when we have the plates placed in the same position in the flat position and the edges are aligned with each other. So, the abutting position, we can say the components placed in abutting position, then this is called butt joint. Then we have the lap joint when they are placed in overlapping position. Okay. So, the different types of the weld joint includes the butt joint, lap joint, edge joint, corner joints and T joint. So, the you see when the plates are placed in abutting position like this aligned with each other, then it is called butt joint. When the plates are or the components to be joined are kept in overlapping position, then we develop the lap joint. Okay. When the edges are used for developing the weld joint, like say the two components to be joined are placed almost parallel to each other and the joint is developed at the edges by melting the edges of the components. When the components to be joined are placed in such a way that the joint is developed at the corner, then it is called corner joint. And the T joint means one plate is placed, one component is placed in the horizontal position, another just perpendicular to that, and a fillet joint or the group joint is used for making this kind of joint, then it is called a T joint. Okay. So, this type of the classification is based on the type of joint classification is based on the placement of the components to be joined, the butt joint, a lap joint, edge joint, corner joint or the T joint. So, that is what we can see from this diagram also. This is the butt joint, this is the lap joint, then the corner joint, edge joint and the T joint. Okay. T joint, edge joint, corner joint, lap joint and the butt joint. Okay. Now, the position in which the welding is done, that is called the welding position. Okay. So, like say the two plates are placed on the table in horizontal position and the welding is done, then it is called the flat welding. Okay. Like this is one component, this is another and the welding is done in this horizontal position. Okay. But when the plates the components to be joined are arranged vertically and then the welding is done horizontally, then it is called horizontal. So, the plane is vertical, but the weld metal is deposited horizontally. So, here the difference here in the flat welding and horizontal welding is, in the flat welding the weld metal is deposited over the plates which are placed in the flat position, but in the horizontal welding the plates to be joined are kept in the vertical position. Okay. And then when the weld metal is deposited this is vertical welding, like say the components are in vertical position, then a weld joint is developed. So, like say in this 3D image, if we see, if the weld metal is deposited along this line, which is a vertical one, then this is called vertical welding. And when the metal is deposited on the lower side and the weld metal is directed in upward direction, then this is called overhead welding. So, if we see, since we are placing the molten weld metal, okay, so it is easiest to place the molten weld metal in horizontal position, that is called the flat welding. Okay. It is little difficult to place the molten metal in when the joint line is either the joint line is vertical or horizontal. Like in horizontal welding, the components to be welded are placed in vertical position. So, here the tendency of the molten metal to fall down will be high, and that tendency will also be high in this case. So, the horizontal and vertical both welding positions are little difficult because it takes lot of efforts to control the molten metal and its placement in the desired position. And the most difficult position is the overhead welding, because we have to feed the molten metal against the gravity. Okay. So, say this is the electrode and here we have arc. So, molten metal will be placed, will should be directed in upward direction to deposit the weld metal. So, this is the location for depositing the overhead. So, means the weld metal is deposited in overhead position. Like say in this case, if the deposited, if metal is to be deposited at this location, then it will be overhead position. Okay. So, this is the like the types of the weld joints and the welding positions. So, basically the flat, horizontal, vertical and overhead, these are the 4 positions. And butt weld, lap weld, corner weld, edge weld and the T weld. These are the different types of the joints, and the types of weld is about the how the weld metal is deposited. Like we have seen the groove weld, the fillet weld, bead weld, plug and slot weld. Okay. That was about the way by which weld metal is deposited. Types of joint is about the placement, and the welding position is about at which, in which position the weld metal welding is done and the weld metal is deposited. Okay. The welding procedure is established first, that is called WPS. WPS, that is called welding procedure specification. So, what is done, like initially the two components to be joined, no. So, we try to establish the different aspects related with the welding procedure in such a way that we are able to develop the joint which will perform the desired function, okay, in terms of the like the properties that are desired from the weld joints. Okay. So, not just developing the sound joint, but also in such a way that it helps to, it performs and it delivers the desired function. Okay. So, there are various aspects related with the welding procedure. So, using the like say the same metal, the different steps are followed and the joint is developed. Okay. And then these joints are tested to see their performance. Okay. If the joint developed using a particular procedure performs satisfactorily, then that the same thing is repeated to develop the actual weld in the real component. But if the performance of the joint developed in the course of development of welding procedure is not performing satisfactorily, then welding procedure is adjusted suitably in order to develop a joint which delivers the desired function which is expected from it. Okay. So, what are the different things which fall in the scope of the welding procedure? One is the edge preparation or the preparation of the material. Okay. So, which will involve cleaning, cutting and removing all the impurities. Okay. So, this is done as basically in light of the section thickness, okay, whatever is the section thickness and the type of the metal. Okay. About this we will talk little later in detail. So, edge preparation involves cleaning and cutting. We can use mechanical cutting, we can use thermal cutting as per the kind of metal, and we can perform cutting in different ways to produce the grooves of the different types as per the section thickness and other purposes which are required, okay, from a given joint. Okay. Then the selection of the welding process, considering the type of the metal, like whether it is sensitive to the atmospheric gases like aluminum and stainless steel, then we will be using the welding processes which provides more effective protection against the atmospheric gases. Then the section thickness, if it is thin or thick, so how much control over the heat input is needed for developing a sound weld joint. Whether if it is very thin, then we need the welding process which delivers the heat effectively such that it is able to develop the joint free from the defects. Like say for thin sheets we may prefer the TIG welding or the laser welding, but for the normal welding we may use SMAW, or for thick sections we may go for SAW, submerged arc welding. So, depending upon the section thickness we may have to choose a suitable welding process. Then the quality requirement, if it is casual welding then even SMAW or gas welding is fine, but if it is like commercial grade, then we will be looking for submerged arc welding or gas metal arc welding process. But if it is for the critical applications, then we will be going for like TIG welding, plasma welding or the laser welding, electron beam welding or the laser welding. So, depending upon the criticality of application quality requirements, the different processes are selected. Okay. So, as far as this one edge preparation involving the can be done using suitable chemicals. So, the cleaning can be done using chemicals or using mechanical like wire brushes or polishing papers for removing the rust, chemicals for removing the all organic compounds like oil, paint, etc., if they are there, or we can club also the mechanical clubbed with the chemical cleaning for more effective cleaning. Okay. Sometimes even heating also helps in cleaning by removing the impurities, like it will be burning and out all the organic compounds and the moisture and removing the moisture from the surface. Okay. So, even certain oxides get thermally decomposed and they get agglomerated when the heating is done. So, cleaning can be done using chemical method, mechanical method or heating, but the thing is when we are using hydrogen based chemicals for cleaning purpose, then in case of the steel welding, okay, hydrogen tends to get into the steel, and when the steel with the hydrogen when subjected to the welding, especially in hardenable steels, then it causes the cold cracking. Okay. So, those kind of the possibilities need to be avoided, like otherwise what if chemical cleaning has been done, then we need to take care of the hydrogen if it has been introduced. Okay. So, this is the only care that should be done, like when the chemical cleaning is being applied and we are using the hydrogen based chemicals, then hydrogen can get into the steel surface, which later on after the welding can produce the delayed cracking or cold cracking or also hydrogen embrittlement. Okay. So, that is the kind of care should be taken. Mechanical cleaning simply can be done using the emery vapor or your the wire brushes, etc. Okay. Now, as far as the cutting is concerned, like the edges of the component to be welded may be rough. So, we need to if it is thin, we need to make the square and straight, so that the when welding is done square and straight, so that the uniform weld joint is developed. Okay. Or if section thickness, so this square and straight edges will be good if the section thickness is less, means it is thin, less than 5 mm, then it is fine. Or we are using the high heat input welding process like submerged arc welding, which can weld the through thickness penetration up to 25 in one go. or we are using the welding high energy density welding process like laser beam welding. So, in those cases where the welding process allows through thickness penetration in one go, then not just in thin sheets, but also thick plates also, we may have to prepare the edges square and straight. So, thin say for your the TIG welding, okay, but if this square and straight edges can be prepared for thick, if we are using the laser welding, electron beam welding, or even plasma welding, or your submerged arc welding up to 25 mm. Okay. So, because these processes allow the through thickness penetration in one go. So, preparing the edges square and straight will also be good enough, but if the other kind of processes like we are using SMAW, or we are using the GMAW, gas metal arc welding process, okay, or FCAW or gas welding. So, in those cases, you see, if the thickness is great, if thickness is too much, then application of heat from the top may not allow the melting up to the bottom. So, through thickness penetration will not be realized, and will be left with the joint which is incomplete. Like say a joint like say this is these are the two plates and a joint has been developed, and so this is the unwelded section. If the through thickness penetration is not realized, then the some unwelded section will be left. So, this will be leading to the defect like lack of penetration. If the lack of penetration kind of the issue is less, then it will be the defective weld and it will not be performing really good. This is about the need of edge preparation. We can go with the square and straight edges, or we have to prepare the edges suitably. So, edge preparation can be of different type, like it can be simple V groove like this, okay, or it can be U groove like this, right. It can be J groove, one side straight and another is like this J groove, or it can be bevel where the beveling is done just one side. Okay. So, this is where only one side the grooves are prepared just from one side, but we can also prepare the grooves both the sides like the V groove like this. So, this is called double V. This is used for thick sections like greater than 25 to 30 mm, okay, especially when we want the no distortion and residual stresses need to be neutralized, then double V are found to be very effective. This requires lesser volume of the weld metal as compared to the single V for the same type of the joint. Then we can use the double like this, double U or double J like this, one side and another side. Okay. So, this is one J and another side. So, similarly we can have the one bevel or double bevel like this. So, this is the double, all these are like double U, double V, double J or double bevel. So, double grooves like whether it is V, U, J or bevel, these are preferred especially when thickness is great and we want to neutralize the residual stresses and reduce the distortion tendency. Additionally, these help in reducing the volume of the weld metal to be deposited for developing the weld joint. So, that is about how to prepare the edges. Now, the second thing is, so the edges are machined out for thick sections and square edges are used. You see, after cleaning, direct welding can be done in case of relatively thin sections depending upon the process which is being used. Okay. Now, as far as the thermal and mechanical methods are concerned, so our metal can be of the different types. So, we have talked about that, like these can be the precipitation hardened, this can be grain refined, this can be work hardened, this can be transformation hardened, these can be dispersion hardened, or these can be just simply solid solution strengthened. So, the point here is these two metals strengthened by these two last approaches, they are not much affected by the heat being applied, but others are affected very heavily by the heat applied. Like say when the transformation hardening metals like this, when they are subjected to the thermal cutting, then all these edges say have been removed. So, the edges which are produced after thermal cutting, they are hardened and they will become brittle. So, later on when welding is done, they create significant problem of the embrittlement and cracking tendency and low toughness weld joints. Okay. So, if the metals, if the metal is such that application of thermal cutting, like the gas flame is one of the most common method, we can use the plasma arc also, plasma cutting or the flame cutting, both can be used. So, whenever thermal cutting methods are used, they tend to degrade thermally the metals in terms of the microstructure and mechanical properties. So, if the metal is sensitive for thermal damage, okay, then we need to avoid thermal cutting methods, okay, because that will be degrading the mechanical properties, that will be developing the residual stresses, increasing the cracking tendency depending upon the kind of metal. So, we have to go for the mechanical method of cutting. So, in mechanical method of cutting, it is simple, like we can use shaping, that is one of the most commonly used method for preparing the edges. So, thermal cutting methods need to be avoided for preparing the edges if the metal is very sensitive for the application of the heat. Okay. So, as far as the welding process is concerned, as I have said, the metal welding process and welding process significantly affect the metal. Why? Because we need to see how sensitive metal is for atmospheric gases, okay, during the welding. If metal is very sensitive, then we will be going for the processes like GMAW or GTAW or plasma, okay, for commercial applications. And if the metal is less sensitive, then we can go for the simple SMAW or your submerged arc welding processes. For thick sections, like for thick sections, we will prefer the TIG welding or the laser welding, okay, laser welding for thin sections. And but for thick sections where we have to prepare the edges, then we can go for the SMAW, SAW, also combined with the other processes like GMAW or your laser and electron beam welding. So, so we have to take a call, like we whether we need to develop a weld joint in one pass or we need multiple passes. So, based on the section thickness, suitable process will be selected. Then the quality requirement, certainly for very critical requirements, critical weld joints, if the quality requirement is too high, very stringent, then we will be going for the TIG welding or the laser welding or plasma welding, because these help in producing the very clean weld we using even with the low heat input. So, this help in clean weld and low net heat input. So, low heat input helps in minimizing the thermal damage that can occur to the metal, and the clean weld will help in producing the more sound weld joint. And if the quality requirement is not that stringent, then we can go for the SMAW or submerged arc welding or sealed metal arc welding or gas metal arc welding processes. Okay. Now, the preheating, as far as the preheating is concerned, many metals, you see, preheating helps in number of ways, but again it will depend upon the specific requirements. Say, theoretically we prefer not to do the preheating welding under the preheated condition, because it is difficult to handle the base metal during the welding when it is preheated. It is like, say, if the base metal is at 24 degrees centigrade, it is easier to handle, but if it is at 150 degrees centigrade, then we need to be very careful for development of weld joints. So, the first thing, it is efforts are made to develop the weld joints without any preheat, but if it is not working due to multiple reasons, then we need to go for preheating. Preheating can be done for multiple purposes, like for reducing the residual stresses, okay, for reducing the cracking tendency, for reducing the embrittlement tendency, okay, for developing, like for developing soft phases, okay, so that embrittlement tendency is minimized, or for reducing the hydrogen content in case of the hardenable steel welding to avoid the cold cracking kind of the issues. When preheating is done, our welding speed is enhanced. Okay. So, the multiple benefits are realized when the preheating is done. So, preheating is particularly used in case of thick sections, okay, like greater than 25 mm, or if the metal is very sensitive to the thermal cycle being imposed, like cooling rate, high cooling rate is troublesome, or the peak temperature. So, if there are cooling rate related issues, or if thickness is too much, then what we do, we try to reduce the cooling rate by preheating. This is one, or by preheating we ensure that the greater depth of penetration is realized and the welding speed is enhanced. So, we can say to facilitate the, the welding of thick sections, the preheating is done, and if the metal is sensitive to the cooling rate experienced during the welding and it causes multiple problems like embrittlement, cracking, residual stress development. So, to reduce the residual stresses and sorry, to reduce the cooling rate, the preheating is used. Okay. So, how much preheating is used? Basically 50 to 200 or 250 degree centigrade preheating can be done. So, moderate preheating is, you see, is done primarily to attain the marginal benefits, but if the embrittlement and other cracking tendencies need to be avoided, then we will be going for the higher preheat temperatures depending upon the kind of metal which is being welded. Okay. Now, when the welding is done, say we have chosen suitable weld for a given welding process, we have selected suitable welding process parameters. So, what are those? We have selected current, voltage and welding speed such that we get the desired net heat input. Once we have the desired net heat input, to realize either through through thickness penetration, or to realize the desired fusion of the barren metal surface. So, this heat input actually once this is realized, then metal will be deposited. When the metal is deposited, it can be done in two ways, like say this is the weld line, metal is simply deposited along a straight line like this, okay, arc is simply moved in a straight line. This is called stringer bead, okay, stringer bead deposition, okay. Or if we want to apply lot of heat and the welding, we are handling very thick sections, then what we do, these are the edges which have been prepared. So, what we do, the arc is moved laterally also when moving in downward direction like this is one way. Second, there can be multiple patterns like this. So, you see, this way we are able to deliver more amount of heat and the weld metal in order to reduce. So, basically the heat input is enhanced. So, this is a stringer bead when it is moved in one line, or when it is moved laterally also in case of the weaver bead. Okay. For realizing the multiple benefits, the weld metal deposition can be done simple, starting from one end and going up to the another end, or it can be another kind where skipping is done. It is deposited in up to some distance, then skipped, then deposited at another location, then skipped like this. Then again you start another location, then again like this. So, 1, 2, 3, 4, this is how the welding is done. This is one where skip welding is implemented. The second one is where the welding is started back step like this. So, we are moving back side, okay, then skip, then again start somewhere else. This is called back step welding, and the one is the upside down welding. Like in this is particularly true when we are dealing with the double groove weld joints. So, the weld metal is deposited at one side like this, then the welding, say this is upside, then welding is done on the downside, okay, like this. So, upside, downside, upside, downside. So, 1, 2, 3, 4, 5, 6, this is how we continue, say 5, then 6 and 6. Okay. So, the welding is done alternatively upside and the downside. This helps in reducing the distortion, and this also helps in neutralizing the residual stresses, neutralizing the residual stresses. So, and besides realizing the many other the thermal damage related benefits when the upside down side welding is done alternatively. Okay. Then we have the interpass temperature and cleaning, like say if we are using preheating, no? So, the preheating means say we have selected 100 degree centigrade temperature in the beginning and the welding has been done. So, when you do the welding in one pass, there will be increase in temperature of the base metal. Then we have to wait for some time until the temperature comes down. This is what is called controlling the interpass temperature. Then you will be depositing another pass, okay, other side. Then it will have some kind of the impurities or like slag or the flux which will be left over the already deposited bead. Then we need a proper cleaning also. So, there are two aspects when we are using the multi-pass welding like this. Okay. So, you deposit one bead, okay. So, heat application will increase the temperature of the base metal. So, wait until it comes down to the specified preheat temperature. At the same time also clean it up properly, so that all flux, impurities, slag, if anything is present on the earlier deposited bead, then that is removed. Okay. And then what we do, we go for the another the pass. After one pass, go for second pass, then third pass, but each pass will be deposited after attaining given temperature and after cleaning. Okay. Once the temperature is attained and the clean the earlier deposited pass has been cleaned, then you will be going for the subsequent passes in order to realize the weld joint in case of the multi pass welding. Okay. And that is the importance of the interpass heating and the cleaning. Okay. Then post weld heat treatment. Once the whole of the weld joint has been developed, okay, like this, then what is left? It is possible at the surface there is a slag. So, the slag has to be removed. So, the cleaning of the slag is done, this can be chipped off. Then there are multiple other possibilities, like during the welding, if the hydrogen has been introduced in the weld metal, then this has to be driven off. So, what we do, we heat the weld joint up to 200 to 300 degree centigrade in order to avoid the cold cracking or hydrogen induced cracking or hydrogen embrittlement tendency. So, this post weld heating drives off the hydrogen which is there beyond its solubility limit. Okay. When the post heating is done, it helps in softening the metal. Softening the metal relieves the locked in strain. Once the locked in strain is relieved, our residual stresses are reduced, and that in turn improves the performance as well as the distortion tendency. So, if we see heating of the weld metal, say in the y x axis we have temperature starting from 200 to 600 degree centigrade for steel weld joints, okay, and residual stresses in the beginning are say 100%. Then as a function, as we increase the temperature, our residual stress magnitude comes down as low as 10%. So, on heating to the high temperature helps in reducing the residual stresses, and that is why it is important that not just removing the post heating of the weld will remove the hydrogen, but also it will help in relieving the residual stresses. Once the residual stresses are relieved, then our load carrying capacity LCC is enhanced, our tensile strength is improved, our fatigue strength is improved, okay, and the distortion tendency is minimized. So, all these things will go in our favor. As I have said, due to the heavy application of the lot of amount of heat, huge amount of the heat, the heat that has dissipated in the underlying metal, like say a part of the metal where fusion has taken place and after the solidification you have got the weld joint, that is fine. But there will lot of metal which will be heated above the critical temperatures, where there will be change in structure and properties leading to the development of the heat affected zone. These are the zones where the properties will get modified, and most of the time these modified properties are not as per our requirement. Therefore, it becomes important to restore the lost properties due to the application of the heat during the welding, and therefore, we have to do the post weld heat treatment. So, when the post weld heat treatment PWHT is carried out, it may be in form of like simple annealing, normalizing, or tempering for relieving the stresses and inducing the toughness. So, these heat treatments will not simply be adjusting the properties, but this adjustment in properties is obtained through the control of the microstructure. Once the microstructure is controlled, then we get the desired mechanical performance, desired corrosion resistance. Okay. And that is why it is important to establish the suitable post weld heat treatment in order to restore the microstructure, mechanical properties and corrosion resistance. Now, here I will summarize this presentation. In this presentation, basically I have talked about the types of the weld and welding positions, and then I have talked about the various aspects associated with the welding procedure and their importance in development of the sound weld joint. Thank you for your attention.